Hi, I am Kumar from Little Eye Labs, co-founder and CEO of Little Eye Labs. We build tools for mobile app development. Otherwise, my company will hit me, so I'm telling this. So anyway, so that's the only slide about our company. So what we're going to be talking here is on Android power consumption, right? Power consumption. How do you optimize? What are the issues that you have to take care of to do power? Power is a big topic. There are lots of things you can actually take care. We will not go into everything, but we'll just give you an overall view of how to actually, what are the things that you have to actually watch for, what are the main concerns that you do, and what you can actually do to optimize. Right? That's the high level. I understand I am between you and lunch. I will try to be as small, and I am also hungry. I also want to go, so we'll try to do it fast. Okay. Why power? Right? Why do you have to worry about optimizing for power? If you take any sample poll of any Android users or any smartphone users, the number one pain point they gave across the board is power. Right? Especially when you upgrade from your earlier smartphones or your feature phones, Nokia feature phones, the first thing that hits you is the fact that you have to keep recharging your phone constantly. So that is a huge pain point for any smartphone user today. Right? This is like samples that we unfortunately can't see. This is like a Twitter snapshot of people complaining about battery. It's good that you can't read it because the kind of bad words they're using, complaining about it is pretty bad. Right? So it is a big problem for a lot of people. It is the users, developers, ad networks for smartphone manufacturers. Everyone is hitting this problem. Right? It's a huge pain. Why ad networks? For example, that article which talks about here, there was a news article from a research institute from US which talked about nothing is free in life. If you use a free app, it's not really free. It's actually impacting your battery life because they're continuously doing a lot of network activity and ads that is actually polling. So it's fine. Somewhere you're paying for it. Right? It's not really a thing. So those kind of things. So it's a lot more visible on Android than on iOS. We all know the reason. We all love Android for the same reason why it is a lot more pain. It gives you unfettered access to your system. So you can just do whatever you want, right? And because of that unfettered access, you can do bad things too. And typically a lot of people do bad things with respect to its power usage. So that's another main reason. And unlike memory, the memory leaks, another thing that we just covered right now, memory leaks in theory you can actually fix. You finally go back and release a reference, you are done. You allocate a lot of memory, one single shot you can actually bring it down. But battery is not like that. You consume. You can no longer get back the battery until you actually let the user recharge, right? So it's a lot more important. And there is no Moore's law for battery. Unfortunately, like CPU and memory, there is no Moore's law. Battery is not becoming better on day in and day out. It is actually the same technology, 18 years or 18th century technology is still being used. Well, not 18th century, but it's not drastically increasing in technology. It's still there's a huge hard limit to how much you can actually package into your battery. And improving is an ongoing activity. People are actually working on it. There's a lot of lithium ion, lithium hydrogen, and a lot of other research is actually happening, but they are not able to get to a commercial packageable limit. And it is not just about smartphones. Your car batteries, right? Your car, Reva cars and everything, they all also work on a similar technology. They all use lithium ion technology. So this need to improve battery is omnipresent, but still it's a hard challenge. It's a chemistry challenge. If there are better chemistry here, you can actually try solving it. And even if you improve, right? Finally, your apps are going to get even more better. You're going to get quad core GPUs, 8 core GPUs, whatever be the things, and you're essentially going to drain those batteries even more, right? So whatever said and done, it is important for you to keep focusing on reducing your user's pain point. Let's just quickly jump on to what consumes power. So when we say an app is consuming power, what are all the aspects that consume power, right? It's these kind of your app's interaction with all these various hardware components, which is the actual reason for why it's consuming power. And then when your phone is in standby mode, which is in airplane mode, it is actually consuming very least thing. But then when it starts interacting with 3G, if 3G is idle, it's fine. But when moment you start sending some data over 3G, suddenly you start draining more battery. Then when your CPU is idle, when it is at a very low frequency, all these smartphones today are all powered to power down, are all designed to power down as soon as efficiently as they can. But moment you start using them, they start powering up, right? So your usage of those hardwares is going to start draining battery, right? And so this is how the drain sequence typically is. This is slightly dated. It's not the latest data. It is like around probably 2 years old, but the approximation is reasonably consistent, right? The left side indexes might change, but the approximation is reasonably consistent. Like for example, CPU on 50% and CPU running on 100% will double, almost double your battery consumption. And then GPS is somewhere there, and then edge is better than Wi-Fi. Edge is so these are all considered. I will get to a little bit more specifics. So for the purpose of this talk today, I will try to focus primarily on network, because as you can see, network is the bigger reason for why you drain battery, and there are lots of things you can actually do on networking. There are other things you can do. If time permits, we'll get to other things, but for now we'll initially focus on optimizing battery with respect to network, right? That's what we'll focus on. So let's get some brief on network. Right? Edge, your 2.2G and 2.5G is probably the most efficient in terms of power on an absolute scale. In the sense, if to send a single byte of data, edge is the most efficient form of communication. But unfortunately, the time it takes for edge to send data is so slow. You can actually send much more data in your 3G and Wi-Fi, and effectively, it is a lot more efficient to use 3G and Wi-Fi. But then edge on an absolute scale is a lot more efficient with respect to power. Wi-Fi comes next. Wi-Fi consumes more power than edge, but then it can do its job a lot more faster. So overall, it is efficient. 3G consumes more power than Wi-Fi and is typically slower than average Wi-Fi network. So again, it consumes more power. 4G, depending on where you are, if it is faster than Wi-Fi, its throughput is faster than Wi-Fi, you might actually be more efficient. And so you actually have to determine based on where you are to be able to figure out which gives the best bang for the buck. So let's get into some more theory behind all this, right? What exactly has happened? So why are this edge more efficient? Why is 3G more efficient and all these things? Basically, for any of these hardware devices, all those radios, 3G radio, 2G radio, Wi-Fi radio, to consume power, they essentially, because of the states they essentially operate on. There are 4 states they actually operate on. One is called as your initial establishment time. Like initially, when you don't have a Wi-Fi access point, your Wi-Fi is actually trying to connect. Okay, is there Wi-Fi? Is there Wi-Fi? Is there Wi-Fi? Right? That is an extremely high power consuming activity. So if you are not in a place where there is Wi-Fi, you should preferably turn off Wi-Fi. This is an end user kind of a thing. But then that's the main reason why Wi-Fi consumes a lot of power. But moment it connects to an access point, after that, for it to maintain the connection, it is very weak. It is very good. It actually does very low power consumption for that subsequent maintenance and for the transmission activity. We will come to what is called a tail state, which most probably you will not be aware of. I'll explain it in the next slides. There's another state called tail, which Wi-Fi is pretty good at. 2G is predominantly good at everything. It has very good, very low maintenance, very low establishment, very low transmit, and very low tail. But unfortunately, it's so damn slow. So when you actually take it all together, it's going to take you more time. 3G is efficient except for the transmit. To send a single byte of data on 3G is a lot more expensive than on 2G. But again, it's so fast, it's overall, it turns out to be better efficient. There are some papers, I'll have more references later. So we'll talk about tail. Tail is extremely important. This is where we as developers can actually make a big play. Because you can't really control all the other things, but tail is in your hands. This is where you can actually make a big impact. What is tail? I don't know if you guys can actually read this. Typically, all these things can actually traviate between 3 different states. Your idle state, this is your standby. You're connected, now you're on standby. This is your low power. Once you start transmitting some data, your devices will switch to a state called low power state. It is thinking, okay, I'm just going to send a few bytes of data, I will just remain in that low power state. And then that low power state basically means it's going to consume less power, but it is not as efficient. It cannot push data in that full speed. If it detects that I'm actually sending a lot of data, then it will switch to a high power state. And as per the name it consumes, I is going to consume a lot more power, right? At least 2x, 3x of your low power state thing. So typically when you, and then moment you come back to your high power state, the time it takes to come back to your standby state is almost 18 seconds. So even if you send a few bytes of data and your application transfers your device to a high power state, your device continues to be the high power state and low power state before it comes back to the standby time for 18 seconds. So every byte of your transfer and then you just stop, you're still going to make that device consume so much extra power, right? So and then there is a latency also involved. Every time you want to switch from a standby state to a high power state, there is a 2-second delay it takes for it to actually switch. Now all those are actually going to add to your cost. So now why is this important? We'll take an example and then see. There are 2 apps. Let's take a case of 2 apps. Both of them want to send 3 Mbps of data, right, through some transaction activity. This first app is actually doing a case where it is sending 1 MB of data and then waiting for 18 seconds, sending another MB of data, waiting for 18 seconds, sending. Either sending or receiving. Let's not worry about sending or receiving, but it is doing network activity of around 1 Mbps with a constant interval of around 18 seconds. This kind of an app effectively will remain in this high and low power state continuously. The whole minute of your activity, the device is completely powered on. 18 seconds of high power activity, 42 seconds of low power activity, right? The whole minute, even though you only took 3 seconds in that full minute, you actually made the device be awake for a whole minute. The other app was a lot more smarter. It figured, okay, I can actually prefetch the whole data in one single shot. It just took it continuously, took 3 seconds, in 3 seconds it read the whole data and prefetched it. Now see the power difference, it's actually going to only 8 seconds of high power and 12 seconds of low power state, right? So if you see this chart difference, you see a huge difference. It's 3x the kind of optimization you can actually do by just changing this. The same amount of data you have done, but then you have actually changed the way in which your code is reading the data, you are actually able to conserve 3x your power consumption, right? So I hope this is clear, right? So Feel free to stop me now, or like I can ask questions later, but if there's something urgent, please feel to stop me, right? So by just changing the way in which your application is actually doing a network activity, you can actually conserve a lot of power, right? So this is the fundamental theory, right? The fact that your devices have this idle states, low states, high power states, there's a tail state, and then the fact that the application keeps switching between all these things is what is conserving, is making your application conserve more power. Here is where you can actually play a maximum. There are a lot of patterns you can actually use to actually optimize. Now let's go to the patterns that you can actually use. The first pattern is obvious, prefetch, like this app 1 and app 2 difference. Don't try to, if you know that you want some data is going to be needed immediately in the short while, don't try to delay that data, try to get it as much as possible in the upfront. There is always a trade-off between like, okay, how do I know how much data do I really need? What if the user doesn't use that part of the data? So Google has a standard recommendation saying if you're going to be needing data for the next 2 to 5 minutes and the data size is around approximately less than 5 MB, prefetch it. Right? This is a recommendation from a lot of analysis, a lot of data network pattern. That's what Google recommends. Right? So the next thing is batch data. Right? So don't try to send and receive it continuously. Try to batch your activity. For example, if you're doing analytics, every time a user clicks on a certain button, don't try to send analytics to your end server. Try to all batch them together and then send them periodically. Right? Because the more frequently you try to do those network activity, more power you're actually going to conserve. The next thing is detect your network connection. If your network is not active, right? If you are in a place where there's no network, you essentially stop trying. If you continuously keep trying to send, you're actually going to unnecessarily wake up your device, try to connect and go on. So stop, detect the network connectivity. There are lots of state signals Android sends you. You can actually start using them to detect. Another thing is avoid polling, use GCM. This is Google is trying to beat us all down with this one. Don't use polling, because what happens is if you use polling, each application is using polling, right? Each application has its own socket connection to its own end server, and you never know when those applications are actually going to wake up. Suddenly some application will wake up, go connect to the end server, and then it will try to send a data. Even if it is just doing a single byte transfer, we saw that device is going to be awake for 18 seconds for a single connection. If that like that, every app in that system keeps doing this continuously, you are never going to let the system to sleep. So instead of use GCM, GCM is saying like everybody talk to the single server, and Google takes care of talking to the single server. There's a single socket connection between you and the end server point, and then Google knows how efficiently to actually do that polling. So if you let Google a single entry point to your all servers use it, that's why it's a lot more efficient. Right? I'm rushing probably because of the content and they're actually pointing me. So next thing is inexact timers. Right? In Android being the way the process management is, like if you use inexact timers, you're a lot better. Unless your app really needs those exact timing measurements, use inexact timers. And even when you use inexact timers, use those thing called elapsed real time instead of real time wake up. Because what happens is when you do wake up, when your system gets that time is actually elapsed, you will be woken up, right? But if you are willing to say like if my device is idle, I don't want to be woken up. If you are willing to let that compromise go, because as far as possible, you should not be the reason why the device is waking up. Let somebody else take the blame. Right? So if you take the if you don't use wake up, you are a lot more efficient. Don't use. It's a simple flag change in your application, but it's actually going to do a lot of benefit to your end user. Right? Another thing is use caching. Right? If I don't want to blame apps, but I can blame apps right now. So there are lots of apps which continuously keep reading data, which is unnecessary. I just went to that same page last time, few seconds back, again it downloaded the exact same data. Right? You want to use caching. Right? Use caching and use variable download pattern. Like detect your connection type. If you are on 3G, do certain things differently. If you are on 2G, do things differently. If you are on Wi-Fi, do things differently. Detect your connection and then be as aggressive as you can, because if you are on 3G, you can be aggressive with your prefetch. If you are on Wi-Fi, you can be aggressive with your prefetch. If you are on 2G, don't be aggressive with your prefetch. Right? Because you know you are not going to finish it at a time. You're actually going to drain more battery. Right? So detect on the pattern, you can actually do things. Another thing which I didn't cover here is another thing called exponential backoff. If you use Google Talk, right? All of us use, most of us use Google Talk, right? If you see the way it actually checks for connection, if your connection is not active, it doesn't continuously keep polling. It checks, okay, first 1 second it will try, after that it will switch to 4 seconds, then it will go to 8 seconds, it will go to 32 seconds. It's called an exponential backoff system. Always use those kind of things when you're detecting, okay, is it a good time for me to now connect and start sending. Don't use a single linear pattern of your usage. Right? Those are all good things. These are all tips from Google. Right? Detect your charge level. If your user is actually charging his phone, you do whatever you want. Who cares? Right? Be as aggressive as you can. You go download whatever you want with respect to your application. Right? Do whatever you want. Yeah, except you're possibly, except you're on 3G. So detect that and then be able to do those things, especially if you're charging. We are talking with respect to power, right? Power, yeah. Okay. So data we'll discuss differently. So next thing is docking state. Right? If, for example, Google actually gives you the ability to say which docking am I using. If I'm on a car dock, right? The car dock means the screen is actually changing to different thing. You don't need to do so much network activity because the user is not going to see it. He is in a car, charging his phone in a car. What is the point of doing all this network activity? Cut it off, right? Detect the connectivity state, we already saw it. If you are on 2G, 3G connected, do it. Manipulate broadcast receivers. This is pretty huge, right? If you use your manifest file to register for intents, even if your app is actually done, you will get woken up, right? Continuously, because if some event comes in, even though you don't want to receive the event at that point, because you have registered in your Android or manifest file, Google thinks you are interested in that event, it's going to wake you up. But if you make it programmatically, say like, okay, once the user clicks the back button when you get this on stop or on destroy events, you essentially say I'm now I'm unregistering my intent receiver. You will never get woken up. Right? So this is a big problem a lot of people do, especially with location based things. If you register using your manifest, you are continuously going to get woken up, even though you don't really want to, and you get blamed for it. Are the organizers not seeing? I'll just move on. Right? So I'm done. So this is with respect to my network activity. There are a few other quick tips with respect to screen and CPU. I'll just quickly cover and then move on. Right? Screen, with today's modern screens, you can actually do a lot of things to actually optimize battery. The power difference between white and black is 80 times, 90 times power efficient. Completely white is, like this is a study from a research paper, is like 100% power versus 10% power on a reasonably dull looking screen. Right? So, but you can actually play with it. If your app doesn't need the full white screen need, you can actually do it. Another thing is your brightness. You can actually control your brightness programmatically, and then if you use a completely white screen, you can actually dull your brightness, and then start reducing your power, right? And then again for CPU, I'm not going to, because it's going to take a lot of things.
I just want to confirm. So even a grey screen will save power.
Grey screen will save power, exactly. If you see the pattern in which Google went from to 4.1, it is all because of that. Right? In your desktop world, when you're using CRTs or your LCD screens, it didn't really matter. The moment you go with true LED, not your TV LEDs. TV LEDs are not really LEDs. Right? They just have LED backlight. Your OLED devices, each pixel is actually having different power consumption. With white and black, there is a big difference. Big difference in power. So CPU again, depending on what frequency your application runs in, it's going to consume more power. Right? So if you can, don't try to, and then the way the frequencies keep changing is because of, like, if you continuously load the CPU, the CPU is going to switch to higher frequency. So if you do your activity in chunks, I do a small activity then move on. Don't try to do all the activity, like this is opposite of what we said in prefetching with respect to network. Right? With respect to CPU, if you can break down your activity into smaller chunks, you typically tend to be a lot more efficient application. I'll just quickly go on. Wake locks, be careful about wake locks. Wake locks are a best friend, but it's very bad with respect to your end users. The moment you forget it, hell is going to break loose, right? So use them only when needed. Screen on, don't use wake locks programmatically, use them in your Android manifest. It's the opposite of the other recommendation. Use it in your manifest file so that you're a lot more efficient and spread out your computation intensive work. GPU is far efficient than CPU in certain activities, but then it consumes a lot of power. Right? So if you don't want to use GPU, don't use GPU, but if you use floating point arithmetic in your code, system will try to use GPU, even though you don't really want GPU. So if you don't need floating point arithmetic, round them all to integers and do your arithmetic. And then use better efficient algorithms, because the lesser number of CPU cycles you spend, the better is it for the end user. Right? So it's pretty hard. All of us will try to use bubble sort for doing sorting. If you use quick sort, you're actually going to save your customer not just time but also on battery. Right? So this is the goal, to keep the reduction. I'm going to just switch to this thing. I just want to show one quick demo because I'm here. I want to show our product here, which you can actually use it to do many of those things. So we have a booth downstairs. Ours is what we're calling as a CT scanner for mobile applications. Right? Which lets you, typically when you do your testing, testing is not good enough when you do just do functional testing. There's a lot of internal activity of your application which makes a lot of difference to your end users. Otherwise, if your functional testing is good enough, you will never have a bug. Right? No customer will ever report a bug. So you actually have to look inside the application as well as looking outside the application. This is where we want to bring in. So you start off by just doing connect your phone. Hopefully this one connect. Right? Connect your phone. It's going to show you all the apps in your phone. Just quickly start. Let's take Angry Birds as an example. Let's beat Facebook. Right? All of us like to beat Facebook. So so Facebook is going to start in my phone. Automatically Facebook started. Now you can forget about our product. You just play with your system. Now you start seeing trends about your application. So you start playing quickly with your thing. So for want of time, I'll just stop playing at this point. This is a very quick test. So once you're done with it, you can say stop. So once you say stop, what we'll actually do is we'll actually pull the video of your application, whatever you just ran test, into the screen now. Now you can actually play back the video and then see like, okay, there's actually a line that is moving. You can't, I don't know if you can see it. It tells you like as your screen activity is progressing, what is happening inside your application. On the bottom area, unfortunately, Facebook didn't do any events. This bottom area is where the events get tracked, because your application's behavior is dependent on what the user does externally plus what the system is doing internally. So this is your external activity. This is going to be your internal activity. All the events like Wi-Fi turned on, display turned on, rotation, wake clock turned on, all those things will start showing up here. And this is what your application is doing, that thing. So it's like, okay, what is my application, how is my application responding to all these events? You can start seeing, and then that shows you a cumulative report on the right side. And you can switch between Wi-Fi and data. If you want to see like, okay, how much was my data sent, how much was my data received, how often am I sending receives, how often am I sending data, you can start seeing all this in a very much more visual way. And this is zero setup, right? I just plugged in, I was doing Facebook instrumentation. This is not instrumented code, I have no code changes, nothing. Just plug in your phone, start testing. So this is the things you can start using, and then you can get these cool reports saying like,
do you have an app running on the phone to collect the data?
Yeah, we transparently push, so you don't have to do anything.
Okay.
So once you connect, we will push an app into your phone.
Okay.
And then you can clean up that app by there's a button say just remove that, reset your device, so that it's much more
Does
clean.
this require a rooted device?
No.
It works without root.
Without root.
So all of this data is actually available on an Android device.
All is available on it. So the way we do is like, so data is true data, right? There are two kinds of reports we actually get you. So, so this is, unfortunately the screen is completely bogus from here, so I can't show you the right screen. But this is all raw data, which is like we query the Linux system. Linux keeps track of a lot of data, we actually get it, and then we get a per app data, and then we show you this data, saying how much was sent in the foreground, how much was sent in the background, how much was received, how much was sent, all that kind of statistics you can get. Another thing with respect to power is modeled, because there is no real power maintained for your application. We actually model the data. We actually read what is power, how is power finally consumed, your usage of CPU, your usage of network, your usage of 2G, 3G, all of them put together is your power consumption. So we actually read those individual statistics, and then we model it on our model device, and then we show you. So which is good enough, which is like 80 to 90% accurate to your any other phone. Any phone you try is going to be close to 80 to 90% usage, right? So that's what we are actually showing. So the whole thing is with respect to integration of, like, it's a lot more visual. There is no coding needed. There is no hard to understand. It's like coordinate your external, internal, your actual applications usage is all there. You can use it to find bugs. You can use it to debug issues. You can use it to get those reports and show it to your manager saying like, I'm all fine, I have no problems. You can use it to do comparisons, saying, okay, last year, this release, did I do a regression with respect to my data usage, my power usage, all those things. And then hopefully soon we'll let it programmably use it so that you can actually connect it to your functional testing. And then say now, without our UI, just functional, as you run your functional test, you can start looking at the inside scan also. And then we'll generate what is called as LEL files, and you can then load them up in this view to actually investigate what actually happened. And then if you're a tester and developer, you can actually save the whole thing into a file, ship it to your developer. Then the developer doesn't have to reproduce the whole problem, he just gets it right there. Right? Now he gets the video, he gets the events. We'll also add support for memory, logcat, threads. A few more things are coming down the pipeline. Right? So it becomes a single pod stop to your testing analysis. And think this is, we work on top of the tools that Google provides us, but we hope to make it a lot more user friendly and a lot more easy to use. So that was my hurricane session. I just finished.
Just want to confirm, this works with any app. It does not have to be a debug mode app.
No. Only your phone has to be in debug mode. Right.
So I can actually take somebody else's app and tell them why they screwed up.
Exactly.
Because it's screwing up my battery.
So we do that, for example, we have signed up with Your Stories. We do, as part of their app reviews every Friday, we review their apps.
Okay.
So we just take it and then try it right there. So it's just a regular build that they got for review. We take it and then review that.
And this is something a user can also use to see what is consuming power on their phone.
If a user is a techie user, we can use it, but it needs a desktop right now.
Right.
And it works on Linux. It works on Mac, Windows, and Linux shortly.
Okay, so we still have a few minutes to anyone ask questions.
Yeah.
Can I ship this along with my app to really collect analytics data?
This is our number one request in the last few days we had the booth. We'll work on it. Right now it is not. Okay. Right now it's a desktop tool available in your desktop environment.
Okay, because there might be a lot of device level optimization.
Exactly. Yeah.
Okay, there might be a lot of device level optimization which we might miss during our dev testing.
Correct. Completely agree. I think it is an extremely important use case, We will get to that shortly. Right now, it is because of the way our modeling and everything is done, it's kind of done at the offline side. So we will get to, hopefully quickly we'll get to that one.
And, in this reports, this is more like a timeline series, like which screens are consuming which battery power. Are you also considering to show like we have a lot of activities and components? Is there a way to pinpoint like, okay, this receiver is staying up for 3 hours, but it's expected for say 1 hour? Those kind of details.
Which receiver is it? Hardware.
There's a
hardware
broadcast receiver in my application. Can it detect such things? This is more like screenshots with with screenshots. I need to map to my activities and my code, right? So is there any code level thing that you are?
So yeah. So right now there is no code level play. The only code level play we have is this events that happen on the bottom. So you can use it to coordinate. The things that we are working on right now is to integrate with Lockcat. Right? So you can actually visually see when you move your Lockcat, you can see okay what exactly was happening in your application, and then down the line we want to integrate that with threads view. Right?
Okay.
So you can actually get the threads view. So
thanks.
Hopefully by next right corner, even before that we will have that. Yes, sir.
Kumar.
Kind of thing so that we can use.
Yeah, just a question. Sorry, 1 minute.
Do you have your beta version kind?
Yes, right now we are on private beta. So next week we hope to go it for public beta. And then month end we want to go commercial. So yeah.
Okay. Thank you.
Right. So littleye.co is our website. You can actually sign up for beta right there. And we have a booth downstairs. That's another place if you want to get some more. Unfortunately, the screen is not very pretty here. Hopefully, if you can come down and see, we will be able to see. Because I think the color resolution rendering between them is slightly off. You can actually see hopefully a better demo downstairs.
Kumar, because this measurement of power which you are saying here, it's not an exact power measurement. It's because you are not taking it from the battery. Yeah. I mean, using the battery level APIs or something to find out actually what is consumed.
Exactly.
You are doing an approximation to find out what all each component in the system is able to draw, right?
Exactly.
So how do you plan to better it? I mean, because this is not an exact.
The reasoning why we don't use the battery level is because battery is your gross system power, right? It is not telling you your app's power consumption. If there is something else running in your phone, that guy's blame is also going to go to you. So it is not just, and you just using that you can't really optimize much because you don't know which took more. Is it CPU or is it Wi-Fi? Because where do you start optimizing, right? So that's where we are actually going by, okay, what is actually consuming power? Consuming power is actually done by CPU, Wi-Fi, 3G, 2G, screen, all those activities is what is actually consuming power. So we will read those metrics and then model power on it. And moment you do anything modeling is going to be an approximate science. It's always going to be around 80 to 90% accurate. But from a developer perspective, this is our hypothesis and based on what we did our research and other things also. Like for most developers, you get an approximate model which is consistent across multiple devices. Is good enough. You are not really looking at exact power consumption of my app to the milliamps or the milliwatts. What you want to know is like an approximate trend. When I did this screen, when I came here, how much was my power? When I did this activity, I unexpectedly was doing it. When I went to the background, how often am I really consuming power? Right? You want to get those kind of relatively approximate data is what you want to get. But we are not trying to say like, okay, we just give you a very, very random data. It is pretty close to standard devices, and we will keep updating our models. So right now we have one model device for which we are showing you this data. We will try to improve that model over time to map it closer to the model device that you are actually testing on. Right? So that hopefully it will become a lot more realistic. In that 80 to 90% will become 90 to 95%. Right?
Okay, another couple of questions. Yeah. One is DDMS actually provides some of these already features, right? I mean, if you want to do a CPU profiling or the memory profiling. So you were talking about integrating with Lockcat and all. Right. So what do you say? What do you pitch this compared to DDMS? I mean,
that's why I think unfortunately this is not coming out as well as it should come. But like if you see the whole usage of this, right? This is a lot more visual way of debugging Lockcat than you would. If you look at Lockcat, you will just see a stream of text, right? Now you don't really know what was I doing at that point of time. You have to now go back and you also want to get a coordination. Like this essentially links it to your screen activity. It links it to your CPU activity, your events activity. It gives you a lot more coordinated review of Lockcat than just a simple review of Lockcat. So similarly with the GPU, the CPU statistics which you get in DDMS, right? That's pretty good, but then that's still not giving it. Just looking at it, it's how easy it is to look at it and really to start optimizing, right? It's kind of hard still, right? You really want to see this kind of a more visual way of being able to figure out what exactly is my pain point. You want to be able to start somewhere first, quickly identify this is the area that I really want to optimize. Then you want to go deeper and deeper and deeper into that area. So we give you that initial quick view of what is happening in the application. You can pinpoint this is the area that I really want to focus on. Then you start using some more tools to get to that. But then we get to the initial one, and over time we will let you pinpoint also. We'll let you show your threads view. So that's saying, okay, this is exactly what has happened, so that you can actually use it to debug a lot more.
Yeah, one last question. The CPU implementation wise, are you using Linux commands over here to get?
So we are using Linux information. We are reading the proc stats and other information to be able to actually read it. We have a native component in our component that we push into the phone.
Okay.
There is the APK component, there is the native component. We use that to actually coordinate and then get all the data that we want.
Okay, thanks.
So there was a question there. I think that guy is gone. Sorry. Any other questions? Cool. Okay. Thank you. Thank you very much. Thank you.